Hi everyone. The next bit of video I have been dreading for a long time. That is because there's it involves a huge component of this arena section of the app, and part of it has been built a long time ago. So it's going to be a lot of explanation if I really want to start from the beginning. But the goal of this video is not to walk through the entire every single line of the code. So, one, I'm not sure if you're actually interested in that. Two, I really would not like to do it because, editing and recording the video itself already slowed me down dramatically. So I really don't know how to record this. So in the Vanly, we say we're going to pivot this video series into Minecraft. No, seriously. I think I'm going to make the video today, and we'll see what comes out. It's been mentioned many times that there are two report view controllers here, and as I mentioned in the beginning of the video, these are partially built out, although you can't see anything. And I'm going to show you what is there. What we want to accomplish here is to show to present the report, which has multiple results of arena games in sort of a grid view or a spreadsheet, if you will. But we accomplish that by using a collection view controller. Um, so this, let me just I think the easiest way is just to show you. So you can see there's something called data in landscape, right? And I'm gonna give it a bunch of data. Nice thing about Swift is you can see the shape. I guess the shape of the data is very well defined in its type. It's a array of anything. So if I run the app right now, I give it a bunch of you know arrays, I guess, and they all have very simple data that is integer. And this is what we get. So right now I'm generating random colors for each grid, basically. If you look at the code here, somewhere I have a random function drand48, and I just give it to the cell's background color, and that's all there is to it. But what's all this rest of the code? What's this landscape stuff? If you have a normal collection view controller and a flow layout, when you turn the view to landscape, you will see four columns. In our case, four columns of grids, and with however many rows counting as still as rows in landscape. So if you say width is x and column is 4, you will have x x row and 4 columns regardless of whether you're in landscape or portrait mode. But look at what happens when I turn this around. We have the opposite. We have X amount of columns and 4 rows. So basically, this collection view retains the shape of its data. So that's what's already been built. All this code here that you probably can't read in time is to make sure that the layout is the way it is. But there's a problem. We actually don't want these cells to be homogeneous, if I can use that word properly. Meaning that, okay, so imagine this. I want to display I don't know, a spreadsheet, right? Spreadsheet have headers, and these are just like one kind of cell, and it doesn't have headers. You to give it a header, for each column, for example, I have to go in here, calculate the whether the cell is a header by its index path, and then specialize that cell when the index path matches the header. And that's a mess, and I don't want to do that. And so all this is to tell you that this view that's being integrated to in our app so far has been refactored. And you might have noticed there's a rigid grid collection view controller right here, and what it does is exactly the same thing as this view. So that's why I chose to show you this, except it's more abstract. It has its own data source, and in it we need to provide a landscape height. So in landscape, that means how many rows, and a landscape width, and that is how many columns, and a cell for landscape position, that is a any UI collection view cell, and then this will this view will happily display whatever cell you pass to it, and it abstracts away all the index path stuff, and all we need to think about is what does the view in landscape look like, and then this collection view will take care of in portrait mode, and it will display the data in its right place. So this data will in portrait will be shown here. So it's that's why I call it rigid grid collection view controller. So that's that. Um, so you can see why why I said there's a lot of explanation to do. But but wait, there's more. Uh, I've since ever since I've refactored this code, um, I've never actually tested it out. So we're gonna find out how well it actually works together. All right, and let's do that right now. I think I'm just gonna move forward by deleting everything in our Arena report view controller. Delete everything here, and then I'll make it a subclass of its copycat, sort of the rigid view controller. Also, the rigid grid exposes a data source protocol, and I'm gonna simply conform to the protocol, and that way I don't have to worry about too much else. We have landscape. Well, let's just take a look first, real quick. Landscape height, landscape width, cell for landscape position. And the reason I'm not getting the autocomplete is because those are actually calculated properties. So landscape height is, let's say, 4, right? Just to keep up with our example. Landscape width is, I don't know, 7. And cell for landscape position is, I think I can simply say, this is a collection view, so self.collection view dq reusable cell with our arena stat cell for index path. So maybe a easier thing to do is retain the index path data. See, that's what I mean by not having this class tested out. There's this little manure details that I didn't even consider, right? For example, here index path might be a very useful information, but I thought, in abstraction it doesn't make any sense. Oh well. So where I actually call it, I will give it the index path. Index path is index path. Okay. Okay. So that's that. Going back to here, now we do have an index path. That'll make our life slightly easier. You can see self.collection view, deq read cell with this identifier arena stat cell and with index path. Sure, we don't really care about x and y right now, since we're just testing things out. And let's say if cell equals this, we say, well, here I will simply return a UI collection view cell. Code should never reach here anyways. And in this case, I just say cell.background. Oh, what's up? Unresolved identifier, of course. Now you can shut up. Cell.background color. Of course, this is Swift. I can simply say white is this random number. Of course, it'll take a CG float here. Alpha, I don't care. So 1, right? Return cell. More error messages. What the hell is going on? Okay, so I know what's going on. This is really stupid. As you dequeue the cell, you actually don't get your collection view cell. You get any object. So that makes it a little better. This will make it even better. So theoretically, let's think about it. Theoretically, this should make it work, except we still need to assign ourselves as the view control, or the source, basically the data source. So let's try view did load. As in here we say super.view did load, and then view self.data source. Self. I think I called it something else other than data source. It's like report data source. No. Grid data source. Yep. Grid data source equals self. So we basically now at this point we've rewritten our cell in the fashion that basically it acts as the data source for our previous rewrite of this controller. And let's test it out. Okay, more errors. View model. That's right. It does not have view model because we haven't declared one yet. So let's declare that. This view model has not been used anywhere, I don't believe, but we have code dependency for it. Arena report view model, I guess. Sure. All right. 1, 2, 3, 4, 5, 6, 7. Turn landscape. So it looks like our rewrite worked. Great. Yay. Now that makes our life much easier because once we're here, we have our view model that we accidentally added back. All I need to do is to replace these static values and these randomly generated cells with our own with data from the view model and a little extra. This is where our the headers came in, right? If imagine this, if I just want to display some kind of data in grid, I don't need extra, especially for arena, right? You can imagine I can have in landscape, each row represents a class that you've played, and each column represents the number of win or loses. So you'll have 0 to 30, 0 to 12 for win, and 0 to 3 for for loss. And now you have a grid, and you can fill it in with the results that you gathered from our record from this basically, and present it in a pretty nice way. Except that's like to display the headers and the number of win and losses, we need to artificially add in the the specialized cells for headers, column headers and row headers. That is where this kicks in because all that logic will be done here, and our rigid grid view controller only takes care of the flow, the layout of, it just knows that, oh, give me a grid of cells, I'll display it and keep their layout in landscape and portrait. So that's very clear separation of responsibility there. In the remainder of this video, we'll simply set up the special logic that I for the headers and the headers, basically the row header and the column headers, uh, and we will stop there um, and come back to the actual filling the actual data in another video. So let's think about it. We can assume that we will have 13 columns plus the column header, so that's 14 columns. 13 columns representing 0 to 13 wins in in one case at least. So the width in landscape will be 14. Similarly, we have 9 classes, so that's 9 rows in landscape, and we will make it 10 rows, counting the header. And that's what we will report to the data, to the collection view. Of course, in the actual data, the view model will tell us, this report view controller, that there are 9 rows. I guess. Oh, well, it will just give it a bunch of numbers, I guess. So what we're really interested in is the logic for the headers, because we're not gonna actually go in and create those cells because that's super easy. Um, all we want here is check the basically return the right type of cells according to their XY positions in the grid. And that's still very straightforward. Mm, so if x and are both 0, we don't really care. That's a special case. So let's do that. If 0 is x and 0 is y, we return. I think I'll still do the return a full-fledged cell since we don't really have um, anything special for these cells except for their colors, and that's precisely what I will try to how I will try to distinguish the color the cells, I guess. So if you're the upper left cell, you're not a header for the any with any specific function. I'll give you a special, I don't know, red color. And else if let's think if 0 is x, right? That means you're at x0 and you're a column header. Let's give it let's give column header a very special color. Uh, yeah, it makes sense to, one way I can do it is to do this if else for xy inside of this DQ block, but in the future we'll be DQing different cells with different I mean still I mean yes, in the future we'll be DQing different kind of cells, so keeping them here kind of makes sense. I mean, one other way I can do it is, nah, this is fine because there will be different kind of cells with different identifiers, and then those cells each need their special customization code potentially. So that's why this structure of the code still makes sense here. For our column header, I'm going to give it a, I don't know, green color. This color, this will look hideous, but all we don't really care, I guess. Mm, else, if 0 is y, by the way, the reason why I write number in the front is because I coded in C for many years, and that's just some habit, some uh, weird habit, either good or bad. Because in the bad old days, the tools used to, well, at least in C, in old C tool chains, they will, if you just say, well, x equals 0, if x equals 0, it will happily assign x to 0 as opposed to tell you that, oh, do you mean x equals 0? So that's why you put 0 in the front and doesn't make any sense to the compiler, and will actually yell at you, and you are protected that way. Anyways, and we're close to the end here, I think. Uh, so if y is 0, you're on the top. You're on the top of the. So you should have another special color, right? We have error here. I'm not sure what it is. Mm, what is the error? Tell me. Expected declaration. I'm messing up with the brackets, or I mean parentheses. Oh yes, somewhere in here we lost a parentheses, I think. What now? Oh yeah, this doesn't belong here. Okay, let's see how it looks. Well, oh, I think Yeah, that makes sense. I believe we have achieved our goal of laying out the little spreadsheet here. And in the future, we can populate these columns with their meanings and the rest of the cells with, you know, the numbers. And here, I don't know, I'll do something fun like emoji or whatever. And we will have our view. And of course, and we have one for non-victory, one for victory. Okay, and like I said, a lot of explanation this episode, and hopefully we can do more action in the future.